Hello, everyone, and welcome to yet another Mitsubishi Electric podcast. And today I am going to talk about artificial intelligence together with Christian Nomine, who is my guest. Christian, could you say a couple of words about yourself?
Sure. First of all, great to be here, Piotr. I've been working with Mitsubishi Electric for 22 years, and I must say that the last 2 years where I was involved in data science and artificial intelligence were actually the most challenging, but also the most fun time for me. So really looking forward to be here and to have that kind of discussion with you. Thank you for the invitation.
Very good. And I think that we will try to go on this journey with you. So you probably will take us through different steps to adopting artificial intelligence. And obviously, today we want to focus on manufacturing industry. So this conversation is going to be more specific, and I can promise I will only use ChatGPT only a couple of times during this conversation. But let's start from the very beginning, and I would like you to define, how do you understand artificial intelligence?
Right. So to try to make a quite general definition, I think artificial intelligence is a technology that allows machines and computer applications to mimic human intelligence by learning from experience via iterative processing and algorithmic training. And that definition is just fitting perfectly to the hype that we have around ChatGPT. So ChatGPT is a solution with a very natural interface that communicates with people using natural language in a chat. And that's why it was adopted so quickly and became a really useful tool for many people in various different scenarios of their work. And that to me has proven that an AI solution needs to be provided in a no-code and easy to use web-based environment. And those concepts are what we also hear from manufacturing companies when they are looking in terms of how to apply AI in industrial context. So this is quite an interesting comparison, but not quite the same.
Yeah, for sure. And I think another difference is that this kind of data-driven solutions are being implemented in industry for a while now. And, I cannot imagine ChatGPT to be, particularly useful in industrial environment. Of course, it has its benefits to, let's say, general audience, but I think manufacturing processes are a bit different. So could you tell us how this is done, particularly in manufacturing environment?
With a constant increase of cost for energy and raw materials, manufacturing companies that we are talking to are striving to use every possibility they have to optimize their production processes. And why do they do it? To become more flexible, more productive, and finally also being able to save cost. So yes, they are looking already into the big topic of data science and AI in order to judge whether it can help them on their journey to really use the full potential of their smart shop floors already. And in addition to that, companies also have a big challenge lacking qualified engineers and operational personnel. So those companies hope to find answers in AI-supported systems and to also try to transfer human work experience into a guidance system for newly and less experienced operators.
Mm-hmm. Okay, but still I would like to dig a bit deeper into why that would be AI, because I can imagine this kind of lack of experience and lack of skilled labor as a topic that was in the manufacturing industry present for a very long time. So I can imagine, for example, solutions, well-established solutions like pick-to-light systems, which basically show to the operator what kind of equipment to take, how to assemble the product. So these kind of solutions are already out there. And this is only like one example. So why AI is becoming, let's say, the biggest or the most important answer to today's needs?
First of all, you gave a great example with pick-to-light that most probably AI is not the answer for all kinds of manufacturing companies. So what I feel is that the more modern, more advanced and more highly automated companies are, the more it is difficult for them to even increase their efficiency even further. So for those companies, AI is seen as a kind of missing key element to even improve their smart factories further. So they are tackling the last, like 5 to 10 or 1% of their production efficiency in order to find solutions to even go into that area and to improve even more.
Okay. So would you say that AI is this kind of solution for, let's say, last mile improvement? Is this how you would describe it?
Yes, that's exactly how I experience it. Correct. Yeah.
And that's how it is done with our customers, for example. Huh?
Yes.
Okay.
Yeah.
Fine. So maybe we can go into a little bit of detail how this can be achieved. So let's paint a picture that we have an organization which is already pretty advanced and their production is running more or less smoothly, but obviously there are always issues. And then they can identify that AI could be a solution for them. So how will they overcome their challenges using this kind of technology?
I think, first of all, for those higher advanced companies, the road to realizing smart factories is already quite clear. Mm-hmm. But sometimes companies are often missing the resources to even invest into these advanced areas even more. So there is budget missing for skilled data analysts and AI experts. And those experts are also quite hard to find nowadays because they would most probably look for a job at Google or Amazon or in insurance companies to do some AI there. So why not putting the human being more into the focus and trying to use existing staff and to put more supporting systems to them in order to start the data journey with existing staff and, like providing them with a dedicated AI data scientist that helps them to explore this new field of data science. And that within a company could also lead to a very high motivation and very high acceptance towards AI-driven solutions, because those people need to be trained more and more in their decision-making process. And why not giving them an AI system that helps and supports them in their decision? And, also from a management point of view, I think that's really, really clear because of the lack of manpower. AI-based solutions can prevent losing process know-how and best practices skills from experienced users. We can take that knowledge and put it in place but not not replacing people, but supporting them and relieve them in their daily workload by using an AI guidance system.
Okay, so it's a let's say very interesting finding, because when I started talking to you, I was expecting that we are going to talk a lot about how to improve productivity or increase the quality, and in fact, those were some of the topics that I covered in my previous conversations. But what you are presenting here is that AI could be an answer to the problem of the expertise, and the knowledge transfer between different generations. So this is interesting because it seems like industries have exactly that problem, as you said. So it's very interesting. Okay,
that's exactly the case. Yeah.
But let's again try to paint a picture. So let's assume that we are talking about organization that doesn't have any experience with AI. And as you said, they are not able to find data scientists or any other skilled people in this area. So let's stop talking about the tool itself, but let's talk about the framework. So how such organization with no experience would be able to actually adopt this kind of solution?
Okay. So Mitsubishi Electric has a long proven record of working with customers to achieve cost reductions and productivity improvements through digital manufacturing solutions. And the best approach for us that we learned over the years is using, in combination and cooperation with our customers, is using a smart manufacturing Kaizen level concept. This has proven to be very successful because it's a, as you say, framework there where you cooperate with the customer. You start, first of all, exploring where the customer actually is, what kind of level of maturity his automation has achieved already, and then also paint a picture where he wants to be and where he wants to go. And then dividing this path into several smaller steps, where every step is a small area of improvement, but with a very clear and very obvious return on invest for the customer already. So instead of attacking like one big project, you just split it into smaller parts, and that makes it also very transparent. And in combination with global experts, we definitely can also provide a really well-matching solution for each customer individually. And as you see, this is not even touching the whole area of AI. AI would be like the top of the iceberg, but again, we provided those kind of improvement solutions, very successful also for a long time.
Mm-hmm. So actually using this SMKL as an example, this is how we can identify basically whether solution like AI is proper for us. Yeah. So I use this example of Pick to Light, which is a very good solution to start with. For example, if you are still on a very early stage, then Pick to Light might actually support your quality and speed of processing and assembly and so on. But using SMKL to investigate where you are, you might realize that you are way too advanced to adopt this kind of technologies, right? Yeah. Great. And then kind of like based on the SMKL framework, you can actually understand that for you, probably AI makes more sense now because you are already, as you said, on this last mile of improvements, right?
That's correct.
Yeah.
I couldn't have explained it any better.
Thank you. Yeah, and because this topic comes almost on all of my conversations, and what we also see is that instead of, tackling like a huge problem of, implementing and improving everything at once, our customers and our, partners, they prefer to start from a specific part and then move forward. Yeah. So it seems SMKL is just perfect for that. Yeah.
Right.
Okay. But let's go back to AI. I mean, that's our main topic. And I try to make those conversations as practical as possible. And maybe we could discuss some sort of an example. I know that there is already some hype around AI, and I know that you have been working, as you said, for at least 2 years with various types of companies. So could you share some examples of implementing AI in the, let's say, industrial places? Yeah.
Right. So one area that I would like to start with is predicting machine abnormalities. So we are investigating whether AI can help in a typical scenario where you have a breakdown of machines and faults in lines, but actually using standard automation technology, you cannot really find out and understand why these breakouts happen. So it's trying to find a system that is actually able to pre-warn the operators that something runs from the normal into a kind of abnormal state, and to then define measures in order to actually prevent the standstill of the machine. So these kind of advanced scenarios are really, really interesting for customers. And of course, it depends on different types of machines, different scenarios, what customer would like to look for. But this is definitely one area. Another area that we mentioned already a couple of times before is to try to learn from experienced operators. So we are taking a data set from an actual production where an advanced operator has already made like perfect operations with this kind of equipment. So he actually knows exactly, based on his stomach feeling and his experience, how to optimize and how to drive that machine in a perfect way. So why not taking this knowledge into an AI and try to mimic this experience in order that also younger generations would be able to use those machines on exactly the same quality and productivity level, thanks to a guiding system based on AI.
Okay, but so we are coming back to this knowledge transfer, and what you just said is actually very interesting. So what you're saying is that in factories, a lot of decision making is still done by experienced operators who just simply know the process and know how it will behave.
Yes, this is what I learned already from a lot of customer visits. Absolutely, yes.
And then we would be utilizing AI in order to, let's say, pack this experience into solution that is working without, let's say, human interaction a little bit. And then this experience and knowledge is transferred into this kind of black box so that the younger engineers can also use this expertise.
Well described, yes.
Okay.
Definitely.
Okay. Any other examples?
Well, the third one that I would like to talk about is an actual project that we have with a customer. It's a water authority. So the question that we ask ourselves here is, are we somehow able to predict the drinking water quality? And, typically those companies, they have a technology expert and that executes spot checks, walking around in different remote locations of his plant, taking water samples, sending it to the lab, receiving the feedback. And then, in a simple scenario, one chemical process value would be out of range. So he knows by experience this water would now most probably not be potable anymore. But he also might have a challenge that in some situations, a combination of process parameters are, not really over the limits, but they somehow feel not right. So he might even, based on his experience, issue a no drinking warning to the public. So in that situation, we are investigating whether AI could actually, in combination with intelligent IoT devices, to directly measure the water ingredients on site, could this AI deliver a guiding system? Again, it's a guiding system to the expert, enabling him in a faster decision-making process and even giving him more safety to actually decide. And, this is a very critical topic, actually, because there's a health of people is depending on that. But can AI help in that prediction process to make the system more effective, faster, and actually, this is a great project that we are working on right now, and we are really great to be involved in that.
Yeah, and it's funny that you're saying that, because I also had conversation about the chocolate production.
Yes.
Where you have almost the same situation when there is this experienced guy having all the knowledge about how to mix specific ingredients and making the chocolate the best that it can be. But again, it's based on it's his own experience. But somehow I feel like this kind of example with drinking water is much more important, right? Yeah. Because at the end, water is something that we all need. And, like relying on, exactly, and relying on AI to make it clean and drinkable, for me, it's like an amazing example. And by the way, I also heard about, let's say, another implementation of AI where it is used to predict early symptoms of earthquakes and tsunamis that could be, caused by the earthquakes, right? So it seems like we have water under control thanks to AI.
Yeah, so many different scenarios where Mitsubishi Electric is involved in AI. It's really, really fantastic. Yeah.
Okay, so but let's take one of those examples that you already worked with, and basing on that experience, could we go through, let's say, the process of establishing solution like that? So again, if you would recommend the first AI project, how would you start it?
So first of all, it's not as easy as ChatGPT, but in general, I would propose 4 phases of the project. And it all starts with deciding with the customer, again, where he actually is and what kind of benefits he wants to have using such data analytic systems. So set specific and measurable goals together with the customer, together with the management. And then only then you should enter the second phase, which is like investigating what data is available on this specific use case. Maybe you need to think about adding equipment, adding sensors, adding more signals on that kind of specific area. But once we have a data set, we can go to the third phase, which is basically analyzing the data and establishing a system which in the first step needs some data pre-processing. You might have, for example, missing data samples that you need to add manually. So once you are really great with the data set, you need to select what could be the right method to give a great prediction. But finally, also, once you have found a prediction model, make sure together with the expert that the precision of that model actually matches the use case and that it can deliver some really good prediction. And that can be used then in the fourth step, which is more or less like an online diagnosis step, where you implement those systems. You get continuous data coming in from the process. You compare that against the prediction model. And finally, the output should be something that is of value for optimizing the process. However, that kind of value actually could look like. That's totally dependent on the customer specification. It could be, the example from the prediction, as simple as something is out of normal. Dear operator, please go to the site and check what could be the problem.
Okay. So you are making this kind of division between the offline analysis and later the online analysis. And I think this is a very important differentiation because, well, personally, I can only imagine okay, analytics or analysis is analysis, right? But you're saying those are like two different steps, and there was also like a small chart explaining this to everyone. So could you elaborate when the offline analysis stops and when the online analysis starts?
It's the step will be done when, based on your data set, you have found a prediction model that matches your goal. You need to, again, verify that model. You need to make sure that this is in the right way of the customer, how he wants to approve it. And then this model needs to go into an online mode in terms of continuously being able to check the prediction. Where are we with our goals? And to take instant action if the AI announces that the prediction shows you, for example, a deterioration of an important mechanical part of your plant. So it is continuously being monitored against real-time data from the process with a continuous prediction for the operator or the manager that he's able to see this live.
So to differentiate it a little more, so the offline analysis is based basically on historical data. Yeah, so something that you gathered and then you could store it in a database or whatever. So this is the past data. And then online analytics is when you are actually basing on what you have learned. You are already implementing this to the process. Okay.
Perfectly described, yes.
Okay. Very interesting. And I think now we have discussed how to implement AI. We introduced a little bit of when and other questions, but the main question, which is the topic of this conversation, is where is AI? Yeah. So could you tell us, as far as you are concerned, where is AI?
Sure. Mitsubishi Electric has developed a complete data science solution by the name of MyLab, Mitsubishi Artificial Intelligence Laboratory. And that is actually developed with a focus on customer advantages. And probably the biggest customer advantage is to make data science available for first-time users that never experienced any data science job. So we tried to lower the entry-level barrier to use such a tool. And we did this with a technology that we have invented, which is an AI-driven data scientist. And using this software with the AI data scientist, the concept is basically that everybody, normal automation engineers, can start their journey into data analytics. It is also a tool which is exactly like we discussed before, completely covering the two phases of a data analytic project. So you are able to use a data set, let AI help you to find the perfect model, and then apply the model online against real data from the process. So it's one tool for everything. And even though it sounds like it's a tool only for beginners and for starters, it's actually not like that, because MyLab is very scalable and actually can grow with customer expectations. That is both true for a really flexible licensing. It can grow with customer expectations. If he has more demands, we can add like a server client structure, splitting it up into additional data analysts for the offline phase and additional licensing to only execute the online diagnostics. But also there are a lot of manual interaction possibilities in MyLab where those would be more used from a little bit more advanced people, data scientists. So there is a big range of solutions that MyLab can actually cover.
Yeah, but the main point is that it actually reduces the entry barriers, right?
Yes.
So it makes it a bit less difficult to start with, but once you start, as you said, it grows with you, right?
Yeah, the concept is exactly like this, that when you start with MyLab, you use all automatic AI functionalities that the software provides. So it's almost like, step by step guiding you through the project. But then later on, you can use manual operations to change the found model. You can add more logic to it. It's a lot of manual opportunities, as I said, to also follow up on this and to even improve the found method even more.
Okay. I think I have one more question about this, because I imagine MyLab as a kind of like a standalone solution. And let's say you have all your historical data for offline analysis, as you called it. And then let's say you build a model and let's say you grow with the process, you understand the process better, you know how to improve it. But then how do you move this learning to the production process? So you did your job. How do you actually implement it in the production side itself?
That's a great question. And actually this whole topic is also, as I said, covered in MyLab. So what we would typically do is MyLab runs on every PC, well-specified, normal CPU power, normal RAM kind of PC environment. But it also comes with direct connectivity where you can send a feedback directly to the process level. For example, by using a built-in OPC UA driver. So that could connect to equipment, giving a direct feedback to the process. You could also use a more like standard kind of file set using text files, CSV-based files, which could be, imported into some other third-party systems. And another opportunity would be to connect both the incoming data and also the outcoming data to a database. So there's lots of possibilities. So kind of drivers, kind of data drivers back to the OT level, already part of MyLab. So this makes the package really easy to use for the customers. And also, it's a solution which is quite standardized. So all you need is this one package, and then you can start your first learning experiences into the big topic of data science and AI.
But then still the offline analysis part is well separated. So you are able to spend as much time as you need, the computer and learning. Mm-hmm. And then only then you will send the outcome to the equipment, and then equipment can be improved on demand, let's say.
Yes, correct. Yes.
Okay.
Yeah.
Very good. So, Christian, we are actually coming to the end. I will keep you for like maybe 20 more minutes for questions. So, guys, if you have any questions to Christian, it's now time to put them in the chat. But let me try to summarize the whole conversation. And actually, I would like you to do it. So I will ask you this. If you have to select like one thing for people to remember from our conversation, what is it?
Well, to make a very quick summary, I would definitely use the built-in AI data scientist within the MyLab software. Because when I worked with that for the first time ever, it actually proved to me that normal automation engineers like you and me can enter the topic of data science and AI. And that was a great eye-opening experience for me, actually. So yeah, that's the one.
Okay. So your own AI data scientist, that makes us scientists as well, yeah?
Yeah.
Without the education.
Yeah.
So you think I would be able to do it with MyLab?
I would give you a 30-minute training, but then you would be possible to do that, yeah.
All right, then. Thank you for this. It was a pleasure, and I hope you will join me in future as well, and maybe we will discuss this drinking water project at some point in time, how it went.
That could be.
But it was a pleasure. Thank you very much. And as I said, I will keep you 20 minutes more, maybe, just to answer a couple of questions. First of all, actually, there is a comment. I will take this one. So someone is noticed that it looks a lot like Six Sigma. So the whole process, it looks like that, and it's a very good observation. So basically, what we have to mention is that the whole approach to improving productivity, and again, whatever the tool you would use, it is based from bottom up. Yeah. So we start with what we have already in the factory, and we build on that. And all these standards and systems like Six Sigma or total quality management, they are all based on this kind of continuous improvement that is making us better one day at a time. Yeah. And this is exactly how we approach the AI topic. I think this is, of course, there are different ways, but for us, this is the most advised.
Yeah. Just to add on that, actually, statistic process control could be one part of the MyLab solution. It could be one method to select, depending on the use case, but it is part of the MyLab pack. So yes, it is quite a similar approach, but only part of it.
Yeah. But I think that we are talking still about the production side. So we have to be aware what the best practices to the improvements of production sites, and AI is just the newest addition of something that we always knew how to do. Yeah. Okay. Another question: what is the most difficult step to implement the AI today? From your experience, what is the most difficult step?
It's hard to say the most difficult one. So I know from projects that it was challenging to, first of all, find the right process data to predict something with value. So what I mean is it doesn't help just to collect a data set with hundreds of thousands of data and to expect some good output of that. So it's working closely with the process expert to actually get his input. What kind of process points could theoretically be beneficial for that specific use case? And The second thing is, of course, to build a system in, what I called the phase 4, which was the online method, to put the system with a prediction really in place, and even more, to make it a beneficial tool for the operators to improve something in their process.
Okay. All right. Actually, there is many questions, so I will speed up.
That's good. Okay.
But actually, interesting question, and I agree we should ask this first. Are there different standard AI models for different vertical solutions, or like for different areas in the manufacturing, or it is kind of like a standard AI implementation that will learn on the process?
Right now, it's a standard approach. So we have a couple of deep learning and supervised and unsupervised learning methods in my lab, but it's not yet specified on industry solutions. So that could be something that we look into in the near future.
Okay, so AI will keep learning, let's say.
Yeah.
Okay. Similar question, and again, good one. Does MyLab have a learning mode where it can be left to analyze data in real time, say for several weeks? I think this is, again, kind of like a learning mode on the online mode, but I think that's different how it works, or?
Yeah, it is different indeed. And I know exactly where the question is aiming for.
Okay.
It's almost like like an auto-learning kind of mode. But that is intentionally not included in my lab. Because the way that manufacturing companies would most probably implement AI is to do an iteration circle. So they would find a model and actually prove in a realistic scenario that this is beneficial. But if it's not beneficial enough, they would then go back to the design mode, so to say, maybe, add more sensors, more devices, maybe even taking less data could be beneficial to find a better model. But this is a kind of learning and iteration cycle, which is always split into an offline mode. So it's like modifying the model, trying to improve the model even further, and then executing this again in the online mode. But it's not a continuous cycle between offline and online learning.
Yeah, and you still want to keep some control over the way how the whole process is being done. Huh? Okay. Question about the pricing of the solution, I guess, the MyLab, but I think the question is a bit more specific. So does it scale based on the size of the I/O system, for how many parameters you will use in your model, or is it more open, more generic?
That's actually a great question. And I was afraid I need to say a price here, but obviously not. So the MyLab licensing is not depending on the number of points that you want to analyze. It's specified on the number of so-called tasks that you can execute online in parallel. So we have specified 16 different tasks that can run on one machine in parallel. And that even can have 64 models that were prepared already in the offline mode. So the only additional license options that we offer are additional users to do and to create more models. So it's a kind of server-client concept on the top level, and additional licenses for running and executing the model. But you would always start with one complete, it's an annual license for one PC, not depending on the number of any external points.
Okay. Yeah, but I think that one of the most important things that you said today was about that the solution can grow with you. Yeah,
That's right.
So you are always able to expand so-called number of tasks. How many tasks are you executing on the production side? Okay. What are the biggest strengths of MyLab comparing with competition? Maybe just to save time, maybe just like 3 items that you believe are most important.
I think we mentioned this in the discussion already. So it is a dedicated tool for non-experts. So everybody who doesn't know all the open data analytic languages and he doesn't have any programming background, he can start the data analytic journey with MyLab. So we are guiding him. Of course, this means there are, black boxes and predefined procedures. That's for sure. So it's not, and this is, the intention of this development is not to compete with openly available solutions on the market, but it is a tool for normal people to start the data analytic journey. And if some people or some listeners want to try this, they can go to our website, download a demo version, and actually try it out. It is quite self-explanatory because of the implemented AI data scientist.
Yeah, there was a similar question in the chat about the difference between MyLab and cloud-based solutions. And I think the biggest one being that, it's not in the cloud. Yeah, so you are keeping the data inside of the factory, but also what you just said also applies, right?
That's definitely one. Probably we have a more specified functional range in our software because the AI functionalities that we implemented are, of course, based on our long-term experience that we have as Mitsubishi Electric. So, MyLab might not cover all the use cases that are out there for AI, but it is a very great package for improving in a specific area. And I would even say, as I mentioned before, it makes working with AI much more easy than using cloud systems. Not to forget, there's some cybersecurity aspects that I might want to mention. So it is a system that the customer can implement almost on the OT level and really try his first kind of small-scale improvement project with AI.
Mm-hmm. Okay. I see another very interesting question, a bit different than the others. So our guest says something like, I have the impression that AI will be used mainly in companies with advanced technology and advanced type of mentality. Do you agree with that? Or?
Let's say it is right now what we are hearing from customers. But I would say because of the low entry barrier, there are possibilities to also improve for, let's say, not so experienced companies. But this is an individual case that we need to discuss because there might be achievements that can be done with more, standard and more normal automation technology, maybe even with less cost. Yeah, but even, to gain a bigger advantage by just implementing other methods according to the SMKL concept, what we discussed before. So this we can discuss individually.
Yeah, and I think, there is still kind of need for a bit cultural shift. Yeah, so some companies are maybe still a bit hesitant to use this kind of technology. So maybe I wouldn't call it like advanced mentality, but definitely a little bit of mindset change is necessary.
Right.
Okay. Back to practical questions. So we will be mixing them a little bit. The question is, can we fit AI with raw data, or do we have to adapt it somehow? So do you need to refine it, or you can actually, like, whatever you gather from the production side, you can just feed it in?
That's exactly the goal, to be honest.
Okay.
So we can take normal historical data, process data, but we could also think about getting a data set from, in a kind of waveform format, where we have logged data from a drive, for example, that is really important for that process. And we could start what we call a similar waveform analysis. So this would not be based on, like normal production data or process data, but rather on current or servo torque kind of data in waveform format. And we could implement an AI that detects slightest changes in these waveforms, again, in the online mode. And that could be again used to pre-warn operators that maybe this mechanical part will get a problem in the near future.
Okay. I have a question that is actually many questions in one.
Okay.
But let me pick some of the parts. So do you see any restrictions of using AI in existing type of applications? So we are not talking about the greenfield application when you can build everything from scratch. Do you see any restrictions if the equipment is already installed and you would like to start with AI?
This would actually be almost like my normal scenario, to be honest, because with the solution that we provide, we don't need to interfere with existing processes, because first of all, we need some kind of data from the process. Yeah? How much data that is in terms of length of data depends on the use case, for sure. But it is actually almost a process that doesn't interfere with existing processes. So we can, first of all, completely be relaxed in the offline learning, trying to find hidden patterns and hidden improvement options in existing data. Then we might find out that the result is not good enough. So then we go back, and maybe then in the next step we talk about adding more equipment that might be required to make a better prediction model. But yes, this is actually, MyLab would be a great tool for exactly that scenario. But keep in mind, you have to have a goal. Yeah? It's not just taking data, put it into MyLab and see what happens. That's not how it works. You need to set a goal, what you want to achieve with MyLab.
Mm-hmm. I will ask something to follow up on this. So I think today you mentioned that OPC UA would be your, let's say, protocol to go to connect MyLab with any other type of equipment. But let's assume that it might not be possible. I mean, there is an existing equipment that doesn't provide a connection over OPC UA. Can you still adapt to this situation?
That depends a bit on the real case. So, for example, even to create a data set, we would be happy to receive a data set in CSV file format. Because we don't need, let's say, to start interfering with the process, first of all. We need some historic data set, and that can be provided from, an existing SCADA system. It could be provided from a data logger. We could put in, for example, like a data gateway to connect to existing PLCs and to open the data up to OPC. There's so many opportunities and connectivity options. A database would be another one. So each individual case is something we need to check.
But generally, you would associate AI improving actually existing systems.
Yes.
That is the most typical scenario.
Yes.
Okay. Okay, I will move to one or two more questions because we are running out of time. However, if you would like us to contact you, we will also do that and we can answer your other questions via email. Let me see what else I can ask. Okay, this is very specific, so let me skip. Okay, so the question about types of data. Sometimes you get like a mix of data, like text, numbers, and graphs. And thus AI is able to handle this kind of different types of data. In general or in... Okay.
Well, it needs to be provided in some text format. So what MyLab, for example, would not be able to analyze is pictures or graphical data, if that is the intention of the question. That would be done with a completely different AI kind of system. Learning, making a deep learning algorithms based on pictures to decide the quality. So MyLab is looking at either process data or real-time waveform data to start the offline learning.
Okay. Very good. So actually, let me ask the last one, and then we can tackle the other questions maybe later offline. But I think this is really a good question. So do you need, let's say, a Mitsubishi Electric person to install MyLab for you and basically go through the process of, setting up the goal and analyzing the data, putting the online mode? Or can this be done by, let's say, local staff? So I believe that the person is working on in some sort of a manufacturing site. Mm-hmm. Can they actually do it by themselves?
I want to say, yes, you can do it yourself, but it could be difficult to find the real use case. So we do offer consultancy services, but again, this really depends on the use case, on the size of the project. So what I would propose is, if we find a pilot proof of concept, and that has a really good use case with a really clear strategy behind it, then MyLab will be able to be used as your tool directly from an end customer. That's how it was developed, actually. Now, we will support, we will train you on the system, but it's actually really easy to learn it. But then it is on the customer side to actually, bring in the right data, and MyLab will support you, of course, in that step. But it's of course, a learning process, and probably it's an iterative process where the customer needs to go into not only one solution, implement that, and that's perfect. It will always work in a kind of optimization cycles.
Okay, and with that, I believe we have to finish. So sorry for not being able to answer all your questions, but we have them registered here and we will contact you separately. On top of that, we will send you some materials so that you can better understand the solution. From my side, thank you to all of you. It was very great to having you here for the full hour. Thank you, Christian, and hope to see you soon.
It was my pleasure to be here. Thanks a lot, Piotr.
Thank you.
Goodbye.